now we are ready for section 3.6, which is derivative of logarithmic functions. And so here is, if it's in log base e, the natural base, if we're taking the derivative of the natural log of x, it is simply equal to 1 over x. That is the truth. If we have a different base involved, the derivative of some log base a, where a is not equal to e of x, then this is equal to 1 over x times the natural log of a. I mean, it would even work if a was e, because the natural log of e is just 1, so of any base, basically. But that's how you can take the derivative of something that's not base e. So here's just some really easy, quick examples to get us going. Here's example 1. So we have to take the derivative of some functions that involved a log. So a, we have to find d dx of the natural log of the sine of x. So immediately they hit us with chain rule, but that's no big deal. We're good at that. So the derivative of the natural log of x is 1 over x. So the derivative of the natural log of something is 1 over that something times the derivative of the something. What is the derivative of sine? It is the cosine of x, and so that is what it is. So this is actually, we could write this as the cotangent function. That's what that ended up being. Let's see. Let's do b. The derivative of f of x is the square root of the natural log of x. Okay, if we have to take this derivative, first, this is a power rule. So I'm not taking a derivative yet. I'm just rewriting this into natural log of x to the 1/2. Okay, now I'm going to take the derivative. Power rule says 1/2 times the function to the negative 1/2. Chain rule says times the derivative of what's inside times the derivative of natural log of x times 1 over x. This can be rewritten into a 1 over, this 2's in the denominator. This negative 1/2 goes downstairs and it becomes the square root of the natural log of x. And this x is downstairs. So this is really, oh my goodness, I don't know why that is. Okay. I don't know why our dog's acting like that, but there he is. He's a weirdo. Here is c. We have to find the differentiate f of x. So find f prime of x. When the function f is log base 10 of 2 plus the sine of x. Okay, there's nothing too special here. There's a little bit of chain rule, but this has got a different base. So that's why this one's in here. So we would have to use this rule right here, which says that f prime of x is equal to 1 over x, which this is our x in this case, 2 plus the sine of x times the natural log of the base times the natural log of 10. But there's chain rule times the derivative of 2 plus sine of x. Derivative of 2 is 0. Derivative of sine x is the cosine of x. And so that is just some little practice in taking the derivative with logs. Now let's do number 2. Example 2 goes like this. F of x is equal to the cosine of the natural log of x squared. And they want us to find f prime of 1. Okay, let us do this. Let's take the derivative of f of x. What's f prime of x? Okay. Derivative of cosine is negative sine. So it's going to be negative sine of this function times the derivative of that function. So let me just make sure I'm writing this down correctly. Yeah, it's just x squared. I want to make sure the squared was on the x and not on the whole thing. So it's on the x, so that's fine. So we have to figure out the chain rule. So it's negative sine x of the function times the derivative of the inside function. The derivative of the natural log of x is 1 over x. So the derivative of the natural log of x squared is 1 over x squared times the derivative of x squared, which is 2x. And so that is the derivative of that. Let's clean this up. F prime of x is negative, I'm going to move this in front, 2 over x, because one of these x's can cancel, times is the sign of the natural log of x squared? Now, they want us to find this. So we're going to plug in a 1 everywhere there's an x. So this is going to be negative 2 over 1 times the sine of the natural log of 1 squared. So we'll use order of operations. The natural log of 1 is 0. Okay, wait. 1 squared is 1. The natural log of 1 is 0. The sine of 0 is 0. Negative 2 times 0 is 0. So we find that f prime of 1 is 0. That's how we can work that one out. Okay, let me make sure I'm happy with that. I'm happy with that. Next thing we have to do is recall some logarithmic properties. You learned this in college algebra, or at least you should have. And then you got reinforced with that when you took pre-calculus and you revisited logarithms. So here are some log properties. So by this point you should be familiar with them. So let's look at them. There's three, these are the three I'm going to emphasize: the product rule, the quotient rule, and the power rule. So they go like this. The product rule you should recognize. So I guess the log base A of m times n, if this is your argument. This can be rewritten into the sum of two logarithms. This can be rewritten into the log base A of the first guy plus log base A of the second guy. That's the product rule for logarithm. You can use it either direction. If you want to take an expression and compact it into one logarithm, you can move that way. Or if you want to expand it into smaller logarithms, you can go that way. Log base A of m divided by n. This is the quotient rule. This can be rewritten into the log base A of m minus the log base A of n. Again, you can use these equations going both ways depending on what you're trying to do. Also, this is the power rule. Log base A of m raised to the power p is equal to, you can take the power and move it in the front, p times log base A of m. This is the power rule. And again, you can go both ways depending on what the application you're trying to use is. So that's a reminder of the log properties. Now we're going to use those to take derivatives. So let's look at A. Example 3A. 3A says, rewrite using the log properties, then take the derivative. So if we have to take the derivative of the natural log of x plus 1 over the square root of x minus 2, the truth is we can do this because we just learned about how to take the derivative of a log, and we know chain rule, and we know quotient rule, and for derivatives, and we could do it. But it's much easier sometimes if you apply a few of these log rules. So let's apply the log rules. First, before we take the derivative, let's get this in easy shape. So let's see. Let's rewrite this using some of these properties because there's a log involved. So this is equal to, I'm going to just leave this d dx over here, and I'm going to concentrate on this rewriting. This is equal to the natural log of the numerator minus the natural log of the denominator. The natural log of x plus 1 minus the natural log of the square root of x minus 2. That, I just used the quotient rule right there. Whoops, I'm about to fall over. Then we can do one other thing to make this easier on ourselves. Do you see this is really a square root or something to the 1/2? Okay, you can look at it like that, but then you could use power rule and take the power and put it in front. So let's do that. Let's put the 1/2 here because we're allowed to do that because we have a log. Then, if we take the derivative after we've applied those log laws, it makes it super, super easy. Ready? The derivative of the natural log of something is 1 over that something times the derivative of x plus 1, which is going to be a 1 plus 0. So that's what that looks like. Minus 1/2 times the derivative of the natural log of this, which is going to be 1 over x minus 2 times the derivative of x minus 2, which is just a 1. So basically, that's what we get right there, 3a. Let's look at b. b goes like this. The derivative of d dx of the natural log of x plus 5 squared times the square root of 3x minus 2 all over x cubed. All right. Well, let's just do some rewriting. D dx is still there, but let's rewrite this. This can be thought of the natural log of x plus 5 cubed times the square root of 3x minus 2. Okay, let's see. There, I like that. Minus the natural log of x cubed. Okay, that's quotient rule. Now I'm going to separate these using product rule. So it's the d dx of, oh here, I'll just, of all this. So it's the d dx of, let's see here, the natural log of x plus 5 to the third plus the natural log of the square root of 3x minus 2 minus the natural log of x cubed. All right, so now they're all separated. The last thing that you can do that's really makes it super easy is if you apply the power rule. I'm going to kick this power in the front because I have a log. I can do that because I have a power rule. So I'm going to move the 3 right here. This is really something to the 1/2. I'm going to move the 1/2 right there. I'm going to move the 3 right there. And now I'll take the derivative. So I need this notation the whole time. Now I'm taking the derivative. So it's going to be 3 times 1 over x plus 5 times the derivative of x plus 5, which is just a 1, plus 1/2 times 1 over 3x minus 2 times the derivative of 3x minus 2, which is going to be 3 plus 0, just 3, minus 3 over x. This right here is the derivative of that. So using log laws can sometimes simplify derivatives tremendously.